Okay, so again, welcome everyone. Thank you for coming to my talk. My name is Špidlen and I'll be talking about Kotlin. Kotlin is the new language you may have heard. And this talk is titled Kotlin Has Java Found Its Conqueror? So let's explore that and let's see if it has. By the way, this will be a talk, mainly me talking. It's a presentation. That if we have time, we'll get to some code samples as well. But feel free to raise your hand if you have any questions during the talk or if you want to discuss something. This is more like a really open discussion. So if you see anything on the slides that interests you or that you don't understand or you want to know more about, feel free to raise your hand and interrupt me and let's talk about it, okay? All right, so first let's do like a quick intro. So who am I? As mentioned, my name is Špidlen. I've been with multiple companies. I was a system software engineer at NVIDIA. Then I joined Google as a software engineer. After that, I was at Dropbox for 2 years, and now I'm with AirBnB ever since. I'm based in San Francisco. I'm in a historic neighborhood called Haight-Ashbury. If you ever visited San Francisco, you should definitely visit the neighborhood. It's where the hippies were born, pretty much, the whole hippie culture. And yeah, I started working with Kotlin in late 2017, which is 1.5 years ago. Still learning, so there's always something new to learn. I'm not enough in the language. I'm not deep enough to actually know everything, but I think I know a decent amount. And yeah, I actually pretty much committed to write all new code in Kotlin, if applicable and possible, because not all code bases allow you to write Kotlin, but especially at Airbnb, we have this rule that you can choose the language that makes the most sense for the given project. So I do write a lot of Kotlin these days, almost all of it actually, honestly. Cool. One quick disclaimer. This presentation is just my personal view on Kotlin. It should not be associated with any of my former or current employees, okay? So it's just my point of view. There should be no association with any of my employers. Cool, let's see what the outline, what's ahead of us. So first I'm gonna be talking about intro to Kotlin. I'll be mostly mentioning some like bullet points, what is it actually at all, right? Then I'm gonna be showing you some of the basic features, some language basics. Then I actually want to talk about Kotlin 1.3 because that's the newest version that was introduced a few months ago. Recently, they introduced a bunch of new stuff, or actually more like finalized some of the stuff that was experimental. So I would like to show you some insights into that. And then let's, in the last section I named Kotlin in numbers, which is going to be a bunch of graphs of how is Kotlin progressing, what's the adoption of Kotlin, what the numbers are, okay? Cool. Now, before we actually get to Kotlin, I assume some of you maybe wrote some Java, so are you familiar with the Java data class and builder pattern? Maybe not, so just in case, I'm gonna do like a quick refresher. So let's assume you have a class user. For the simplicity, I just kept two private variables, string name and long integer. For the data class, you want it to be immutable, so you create a private constructor where you would assign the fields, data passed through constructor, then some getters, both for the ID and for the name. Then you need the builder, right? So the builder, in this case, it's a static class. It's an internal static class of class user. It has the same private fields, has the since we use the flow interface, it has the name, which is named exactly. This is the method name. This name exactly after its backing field. Same for the ID. Then you need a method to build, to actually get the user object from the builder. So there's a build. And then you won't also be able to convert a user back to the builder. So you need a method to builder, which creates a new builder array, assigns the ID and the name, and returns the object itself. Then in order for it to behave somewhat reasonably, you need to override hash code and of course to string. You also need to override clone in order to get a copy of that. And then don't forget about equals, right? Because otherwise, if you have two objects with the same fields in it, they wouldn't equal themselves in Java, right? So this is plain old Java, simple data class and builder pattern. Now, why am I showing you this? I want to make a point. The point is, in Kotlin, this whole, 40, 50, maybe 60 lines of code can be replaced by this. These two things, this one, and this one has exactly the same functionality, right? I'm gonna explain it later in my talk what these words mean, what the data class means, what's the val and ID in the constructor. But yeah, so just to give you like a taste, you know, you can in Java is very shitty. I mean, in Java you can obviously use some of the extensions such as Lombok or something like that. They will provide you some shortcuts, but yeah, this is actually in Kotlin. This is inbuilt in language. I think this was one of the biggest selling point for me once I learned that you can do things like that in Kotlin. Cool. Now let's actually switch back. Let's talk about intro. So what is Kotlin? Kotlin is a JVM language. What does it mean? Well, it means it runs where JVM is. So and where Java can run, Kotlin can run as well, pretty much. It's 100% on interoperability with Java. It was developed by JetBrains. First release was in 2016, I believe. Current version is 1.3. I'll be mentioning some of the features later in the talk. Pretty much we have a stable version right now where new features are being added, but also at the same time, the development is mostly focused on compiler improvements and some tooling. Interesting point, Google announced the official support for Kotlin back in actually May 2016 on Android, that is. Since then, actually, Kotlin quite took off. Now it's becoming slowly #1 language on Android, pretty much. And also, it's making its way to backend, you know, because a lot of backend services are in Java. So at AirBnB, for example, we do write backend services in Kotlin as well. We do mostly Java, but I'm trying to push for more Kotlin. So yeah, at least in my eyes, Kotlin seems to be the next big thing. Cool. What else is there? So yeah, it's open source. It's easy to learn. I think it's actually quite difficult to learn because I think it's the language itself is very powerful, but that comes at a cost. I'll talk about it later. It's productive, concise, but not the expense of maintainability. This is an interesting point. I think the developers of Kotlin mainly, they want to focus on readability. They want to present as much information possible on the screen without obscuring it. So it becomes concise, but I don't think conciseness is the goal. I think the readability is the goal. And conciseness is a way to get there. One interesting thing, this number actually is something we measured at Airbnb. We converted a lot of Java classes to Kotlin, and on average we got something around like 40% less lines of code, which means, again, you get the same functionality with 40% less of code, which is pretty nice, As mentioned, it runs on any JVM. It can also compile to JavaScript or native binaries. So you don't actually really need VM anymore. Again, this was one of the features that was released as 1.3. In theory, anything, including iOS and web frontend or backend, can be written in Kotlin. I haven't seen written any iOS code in Kotlin, but I was told it's possible. Okay, let's talk about some more about language features. Excuse me. Okay, so Kotlin is statically typed. Also, there's a very strong type inference. What I mean by that is, once you see some of the code examples, you don't have to declare your variables at a given type. Compiler quite often can actually infer what the type it is. Again, that comes back to the conciseness. If you type in val number equals 5, it's clear it's an integer. You don't have to say val number integer is 5. So we already know it's 5, right? One of the things is it's borrowing from other languages. For example, from C#, it borrows this notion of properties. It's actually very well present. I will talk about them later. They are preferred over setters and getters. You can still write your setters and getters as methods as you would in Java, but properties are preferred. Again, this is actually a very big feature I completely love. One of the most common exceptions in Java code base is a null pointer exception. I think at least like 50–60%, most of the errors you get will be from null pointers. Now, Kotlin actually builds in nullable type check into the language itself. So it's actually quite difficult to get a null pointer exception. It's still possible, but you have to try really hard to actually get into that state. It provides better solution for NLPs. It comes with immutable types. Basically, any type, if you use it by default, or not any type, but a lot of the types are immutable by default, which is pretty cool. So when you say list of something, you will get an immutable list. If you want actually mutable list, you have to specifically say, I want mutable list of. Again, data classes is something I showed you before. It removes huge amount of boilerplate and code that it's been repeating all over again. The code bases without actually adding any value whatsoever. Read-only collections, again, another great feature. Thread safety, especially on Android, is very important to have a thread safety. What else is there? Okay, high order functions, lambdas. You probably have seen that before. Java 8 also has lambdas. If you use JavaScript, also high order functions. I'll be mentioning them too. Lazy initialization, you can actually defer initialization of your properties or variables. That would be mostly used if you need to like initialize connection to database or maybe logger or something like that. Extension methods, again, another great feature, actually heavily used across the Kotlin. So any class at this point in your code base, you can declare an extension to that class, meaning it without the need of subclassing it, which sometimes is not even possible because the class could be made final. You can create an extension that can be applied to that class. I'll have a few examples later on that. Coroutines, okay, this is one of the new things that used to be experimental, and I think it got moved away from experimental in 1.3. I have a code example for that. So think of it as a like very, very lightweight threads. Kotlin native allows compilation into binaries natively, so you don't need a VM anymore. Another feature is Kotlin multi-platform. That's an attempt to provide a way to write a code such that it can be ported from a platform to platform without doing any extra, coding. Pretty much sharing code. Again, I have examples for that. It was also released in 1.3. I haven't properly used myself, so just take it with a grain of salt. Okay, let's talk about some language basics, right? Good. So, for those of you who never seen Kotlin, on the left-hand side you have Java. It's a simple function. It adds two numbers, number one, number two. On Kotlin, on the right-hand side you have Kotlin, exact equivalent of that. So what happens when you run this through a compiler? They will actually end up to be the same bytecode. It will be exactly the same code. Now you can see it's very similar to each other. You can probably read it if you look at them. You probably can figure out what it does. Now some differences here. So Kotlin has this keyword called fun, because Kotlin is fun. So for every function you have to actually declare it with fun, and you have a lot of fun in your code. Okay, that's a bad joke. Anyways, then what you do for your types, or you declare the type, be it a property or be it a return type, after after the identifier. So you can see in Java you do integer number, in Kotlin you do number integer, and also return type is declared at the end. But still it is the same very much. Now the one on the right hand side, it is Kotlin, it will compile, it will run just fine, but it's not necessarily idiomatic Kotlin. It's not something actually Kotlin strives for, because I told you it's about brevity and it's about actually conciseness. And when you look at them like this, it doesn't really seem there's much more conciseness, right? They have almost the same amount of letters, the same amount of lines. So let's look at it again. Now Kotlin lets you do a bunch of things. So you can actually omit the whole body because you can use expression directly in your function. So now that already removes 2 lines of code. You remove the return and you remove the curly braces. Now I also mentioned that you can omit the type because the type is inferred, right? Because you already know that those 2 arguments passing in, number 1 and number 2, is an integer. When you add them up together, you can only get integer. So the compiler is smart enough to know that the type is integer as well. And Kotlin actually lets you specify the semicolons. It will still work just fine. Now, they're optional. And I think that's actually one thing that I really don't like, because then it just creates arguments. Should there be a semicolon or should there not be a semicolon? So you can omit it, but I'm sure there'll be people who would insist on having them there. So it will create a lot of churn in terms of code styles. But we try to write it without semicolons. There are some cases when you need them, but in this one you don't have to. Cool. Now I talk about properties. So instead of getters, setters, Kotlin actually uses properties. So let's talk about properties. So this is a simple class person. Think of the one we actually created before, has a name and maybe ID. Some setters. So we have a set name, right? Now in Kotlin you would write it like this. The property becomes, you don't use method in your name, you just use property directly like this. So when you have .name, on the right-hand side of the equals, it becomes a getter, like in this example. When you have it on the left-hand side of the equals, it becomes a setter. So again, those 2 left and right on Java, Kotlin would be exactly the same code. Now, you can also declare your property in a way that it has a custom accessor or custom getter. For example, here, I'm actually overriding the set value, and I want to just have some validation. Let's see, we have property called address. This would be the actual value. You can validate it. Let's say you have some address validation, and the field is like an implicit keyword, which is something called backing field in C#, where you would actually store the value. Similarly, you can also override a getter. So in this example, you just write get and what get means. So get actually, for example, checks if the address is empty at this point. Okay, let's talk about properties in constructor and name parameters, because again, I think that's one of the greatest features in Kotlin. It removes so much code. Remember overriding constructors every time you need to provide like different argument types or different, default values. In Kotlin, it's super simple. So this is how you define properties on class. You have class person and you have variable. Var means it's a read and write, so it creates getter and setter. Val means, think of it as a value. It's read only, so it will have only getter. You cannot set this one. You can set it only once. Think of it as like a final in Java. Now, if you transfer this class a little bit into this type, so this parentheses are actually is a type of default constructor. So now we have arguments in that constructor that's an ID, and the default value for that one is 1, and then we have name. Default value for that name is John Smith. But because we also prefix it with the val and var, it also creates the properties on the class. So pretty much you will end up with class person that has two properties. One of them is read only, and it has default constructors with default values. Now the funny part is that the Kotlin will generate all sorts of constructors for you. So then you can actually create your class person like this. You can just do default values will be used for both of them. You can set both of them in the constructor. You can also just set one and then the other default will be used. Or you can use name parameters, meaning you can set the second one currently with the name. So again, it removes a lot of boilerplate overriding constructors. Or you can even like reverse them. Like remember, ID is the first one here, but the ID here is the second one if you use out of order naming. I mean, it's not probably no reason to do that really, but it's possible. Now in Java, what you would have to do to achieve kind of the same behavior, we would have to probably declare like 5 or 6 constructors with different types and different default values. Really annoying. Here you can just do it in pretty much one declaration. Now nullable types. I love this. This is actually a way to get rid of the null pointer exceptions in your JVM language. So let's talk about it. This is the special operator, question mark dot. Now the way it works, let's look at the Java again first. Let's say you have some user data and you would like to extract the house number from the user data. Now let's say that you know that every single field on the user data can be null. So the data itself can be null, the user can be null, the address can be null, and maybe at the end you get a house number, right? So pretty much you would have to write something like this, chain it together, and return null if in case it's null. On the other hand, in Kotlin, you just do this. And again, this will be exactly the same code. Now the way it works, this operator, the special safe call operator works is if the left-hand side is null, then just return null. Otherwise, call the right-hand side. So it kind of bubbles from data to user, from user to address, from address to host number. So if any of these will be null on the way, it just returns a null without failing, actually. It's a great thing because then you don't get that exception, right? Now, we also need to talk about then nullable types here. So in Kotlin, each type has sort of like think of it like a different state. In Java, everything can be null. You have user data, it can be null. You have integer, it can be null. Now, in Kotlin, if you declare just int, like this, it actually cannot be null. It has to have a value. By the way, I think this is a typo. There should be a question mark here too. Now, what happens is, if you have a nullable type, you just declare it with a question mark like this. And that means Kotlin tells you, well, there is a null or there is no null. I don't know. It can be number or null. That means you will have to propagate that information upstream, right? Now let's look at the nullable types, how the Elvis operator works. Now that's another operator introduced in Kotlin. It's a question mark column. And the way it works is, if the left-hand side of that operator is non-null, then execute or return that. If the right-hand side is null, sorry, if the left-hand side is null, then execute right, execute B, for example. So if x equals A, Elvis B, then if A is not null, x will have A. If A is null, x will have B, meaning if B is null, it will still be null. But it's actually a nice way to provide defaults, right? So we can do something like this. You have a nullable text, which is type of string question mark, that means nullable string. And you can assign it directly, and it's just fine. Then, if you want to get a length on this guy, then this length would be also possibly null, right? But if you provide a default value here, you can just declare it integer, non-nullable integer. Another interesting part is it can also serve like as a early return. So if you, for example, has method something like this, when you want to verify whether a user can access the entity, and you know the entity could be null, in theory you can get it from database null, then this thing will get executed return false. Now, it will not assign anything to the entity itself. It will rather just finish the method. It's kind of like an early bailout, early return, and return immediately false. Same for this guy. If your context provider does not get the user, or any of these is null on the path, it will just return false immediately. And then only if both of them are not null, it will compare them towards the end. You could, in Java, you can see how it could do the same thing, right? You can do is not null, return false. If this is null, return false. And then you do the kind of nested structure, and it becomes so difficult to read. But this one, again, just one simple line does all the checks for you. Again, I think that's actually very cool. Now, there's this operator. I'm actually not super happy with this one, but it's kind of necessary. So think of this case. If you use this double bank, it actually typecasts that object into a non-nullable type. It's kind of like forced casted. So, compiler normally would complain here without the double bank. It would say you cannot assign, you cannot call length on a nullable string because that nullable string in theory can be null. And in this case, as you can see, it is actually because I'm assigning to be null. And it would not let you run it normally. But if you use this double bank, it actually will force it to be non-null, and then it will return the value of the length. Now, this is nice. Many actually see it every time people start with Kotlin. They have all these random null constraints, and they actually start using this. And I don't think it's a good thing because there should be actually no use for it really. Like there is zero use for it. There's some use cases. Can you think of some legitimate use cases for this thing? So some of them could be perhaps if you have like a third-party library that was written in Java or some other language, and it returns something that's nullable, but you already know it's not null, and you cannot go and change that code, right? So if you have like a legacy code or something. So at that point, you might want to typecast it to be non-null. If you all know that this method never returns null because I saw it written, but I cannot recompile it, to change the type. So there are some use cases, but it's very few actually. Mostly people just try to take shortcuts, and this is actually what will result in null pointers again. This would actually throw null pointer exception, by the way. This is one of the few cases where Kotlin can throw null pointer exceptions. Now, we already seen this data class, right? This is the one from the beginning. So let's actually talk about it, what these things mean. We already know that this is how you declare the properties through the constructor. So you have the value, read-only property of ID, which is long, defaults to 0. Again, value, name of string that defaults to null. Now, the this part is interesting, this data keyword. This data class actually allows you to, it does a lot of things for you. It overrides the equals and hash code to behave reasonably. It also generates auto to string for you, so you can print it easily. It adds those properties. Well, actually, the properties are auto-generated by default from the language. They are not generated from the data class. But also auto-generates the copy. The copy is actually a nice way to create sort of like a builder pattern. So the builder pattern and the data class, they are not exactly the same, but they achieve the same thing through slightly different methods. Now let's look at the example. So we have this user. We can actually create a user. By the way, I probably haven't mentioned it, but you probably figured in Kotlin you don't have to say new. It's not needed. Again, if you have just class name with braces like this, or sorry, with parentheses like this, then it knows it's a constructor. So we have user 1. Now if you print user 1, you will get user ID 0 because that's the default value, and then we added John Smith was the name. Now you can use this copy method, right? So the copy method lets you actually create exact copy of user 1, but then you actually have to specify what you want to override. So I'm saying I want to override now ID 2. So for user 2, I'm gonna get the user with ID 2 and name John Smith. Now, interesting part is if you actually try to compare them, say equals, you get false. I mean, it's obvious because they have different ID, right? Now, what you can do also, you can copy back the user and you can actually change the number to 0, and then you actually get equals true because they do hold the same values at that point, user 1 and user 2. Okay? So this is actually very short into the data classes. I mean, data classes are actually very simple, and I think they're actually very powerful too. Another thing I actually find pretty neat is destructuring. So if you ever used, I believe Python has it, and I'm sure some other languages too, you can destructure. So again, let's look at the data class we already had, the family 1 user. Now you can create a new user, and this is what destructuring means. You can actually destructure, like literally take structures from more complicated class and reassign them to a simpler ones like this. And then you can access them directly like that. Now you can actually maybe not see how this is helpful, because you can always type in, u1.id and u1.name. Sure, that's true. But then actually it very works well in loop iterations. If you have loop, you can just have like a key value pair or something. You can just do key and value in collection like this, and it will destructure properly from a hash map or something like that. So it's actually very nice for loop iterations. Now, extensions, I already mentioned them before. Extensions is a way to add an extension, literally, to a class that's either final or you don't want to subclass it from it. Sometimes subclassing can be really hard and really tedious, but extensions are actually a nice way to add methods to an existing classes. The way you do it in Kotlin is actually very simple. You just declare the class name, whatever you want to extend. Right now it's a mutable list, and I actually want to add a function called swap, right? This function will take two indices, index 1 and index 2, and that's pretty much it really. Then just declare the body. So the interesting part about the extensions is the keyword this. So if you write an extension method, the keyword this within the context of the extension method is the object itself. So this in here on this line refers to the instance of a mutable list you're executing the extensions method on, right? So similar to this one, for example, we can add string dot is capitalized on Boolean. Implementation could look something like this. Now, there's two interesting things on this one. There's something called all, and there's this curly braces, and the it is uppercase. Now, let me start with the it. The it is a kind of, it's not really a keyword, it's more like a convention to call things it, but it actually works in a way that the compiler knows. So let me actually go back to the all. All is another extension method on a character sequence. String actually subclasses from a character sequence. So this all gets inherited from the character sequence. It takes a predicate, and this is the predicate itself. This is the lambda function. This is the higher order function that gets passed in through the all, gets executed on every single element, and it's true or false based whether it's actually capitalized or it's not. But this it is actually shorthand where you have a simple lambda function that only has one argument, then you can refer it with it. Again, it's like a shortcut. People get confused by that, and I can see why, but once you get used to it, it actually makes complete sense. So this it is this character here from this predicate. I know maybe it's not obvious, but once you would see the code, it would make more sense. Just bear with me right now. Cool. Now we are getting actually to Kotlin 1.3, which is the latest release of Kotlin. I'm gonna be mentioning three things, namely Kotlin native. Just basically what it does, it compiles into iOS, macOS, Android, Windows, Linux, WebAssembly, and all of them are native, so you don't really need the JVM. I actually personally never used this feature. I know it's there. I know people who used it, but I haven't really used it that much. But I can see how this can be useful if you go for performance, or if you just don't have the possibility to have the JVM around that instance. Now, also, just one thing to be clear, this does not necessarily the native part doesn't allow code portability, okay? It can be portable, but it doesn't really require that. So that's what multi-platform is for. So this one actually allows for sharing the code. Now let's actually, they use two different keywords called expect and actual. I'll show you how it works in the code itself in a second. And it's mostly for shared libraries. I can't really see how they would use it for whole applications. I think it's not there yet. I think it still requires a lot of work to be able to just write one app once and make it work everywhere. But I think it's a great tool to use for shared libraries. Now it could be used for some of the tedious tasks that you need to re-implement all over again, such as serialization of some data structures. Could be a JSON, could be proto, whatever, proto buffers, whatever you guys using. You can handle pretty much HTTP requests and some serialization and exception handling for that, right? Perhaps logging too. Coroutines managing is a good example. Cool, so let's look at the example how it actually works. So this one is for logging. So you would define in Kotlin your enum for different types of logging. Then you define your functions. Now, this is actually shorthand for that this method just calls this method. Now, this method, this function, is the one that has the keyword expect, right? So think of it as sort of like an abstract way of how to declare a method. So it has no body, it doesn't do anything, it's just there. And this code actually will not compile on its own. It actually requires another method with the same name that would have the keyword actual. So for example, if you use a JVM, you could have actual implementation, write log message such that it just prints, so it actually implements, this is the implementation, prints log level, which is the one passed in, and the message itself. Now, if you were to, use this library in JavaScript environment, you could actually override it, or you could actually provide a different actual implementation, which could look something like this, right? It's a simple example, but I can see how it can be powerful enough. So you sort of like declare the interface itself. Think of it as an interface method. I think that's a really good example, or abstract method. And it uses this keyword expect. And then it needs to find a matching partner, which will have exactly the same signature, but it will have the keyword actual. And this one will be platform dependent. This will be the actual, heavy lifting. But the logic for, handling all the, like a level up logic can be all shared. So yeah, this is the multi-platform example. How much time? Okay, we still have some. Okay, let's look at coroutine. Excuse me, I just need to drink a little bit. Let's look at it, coroutines. So it's a new asynchronous framework for Kotlin. Again, in the previous version it was experimental. I haven't really used it that much, but now they introduced it like fully supported. So I think we're gonna be using it more. I think that's actually very cool. Traditionally, in order to execute some asynchronous code, you would have a future promise, or a callback. But something, if you heard this term before called callback hell, that happens if you use callbacks extensively or futures. It's really becomes very, very tricky to actually maintain them properly. And to propagate exceptions specifically through callbacks, it's also very, very tricky. Now, coroutines actually provide a nice way of writing asynchronous code in a synchronous syntax. I know it sounds kind of weird, but bear with me. Once you see the example, I think it will make sense. And what happens is that the compiler actually will recompile your synchronous code into the asynchronous version of itself. So you don't have to manage all those continuation tokens or whatever you would be using. The compiler actually does it for you. Coroutines actually also very lightweight comparing to threads, for example. They take almost no resources. Okay, so before we actually go to the example I have on the slides, let's actually quickly switch to the code. Let me just open this guy. Cool. Can you actually read it? Is it big enough? I can probably zoom a little bit. Let's see. So this is an example of coroutines. I wrote two simple methods. So let's look at the first one, this one, the function main threaded. So this repeat, what it does, it runs 20,000 times this part of the code. And the only thing that happens, it creates a new thread. The thread sleeps for a second, and then it prints a dot, right? And here what I'm doing, I'm actually measuring how much time it takes. And I'm sleeping here so I can print the actual result, okay? So I'm gonna run it right now. This is the threaded version, the one actually using the threads. It creates 20,000 threads. Each thread sleeps for a second and prints a dot. So actually, by the way, before I run it, any guesses how much time this code should take to execute? No? Anyone? So, what happens is those threads keep getting executed, right? Each of them sleeps for a second. Presumably, all of them would get created immediately, and they would all sleep for a second and finish immediately. So it should take less than that, but it actually takes almost 8 seconds, right? Now, if I'm gonna change it to the exact same code, repeat 20,000 times, instead of thread, this launch method actually creates a coroutine, then it delays like a sleeps for 1 second and prints a dot. Let's see how much time does this one take. So this one takes actually 1.3 seconds. The threaded one took almost 8 or 9 seconds. So the threads are actually very heavyweight. Given the fact that it does exactly the same thing, the coroutines are much more lightweight. So that's what I want to show you, okay? So let's go to the next slide. Now, an example how you might want to use coroutines or threads in general. Let's say you want to upload an image to S3 from your phone, right? Now, there's many ways to do that, by the way, but this is just an example I kind of came up with that actually works in production well. So your client, let's say this is your iPhone or Android, it actually talks to your app server, it requests a token or pre-signed URL. Think of it as a simple token. Now then in step 2, it actually uses that token to talk to S3 or Amazon server to actually upload the image. Once that succeeds, then it talks back to your server saying, I successfully uploaded the image, okay? So there's like a 3-step upload, 3-legged upload. You can see how these are actually very heavy I/O operations because you always wait for the network. And you can also see how they have to be done one after the other because they depend on each other. There's a strict dependency on them, right? So using coroutines, you could do something like that. You use the keyword suspend. This actually defines a method that's a coroutine. Then obviously I actually didn't do the whole implementation, but assume I would normally, there would be like some request to a server. I just did delay 1 second just for that and then return like a fake token. So you get the pre-signed URL, you upload to S3 the actual image itself, and then you confirm. And this is actually the method you have to write, just like this. You use the global scope.launch, and then these are the synchronous way to actually write the code. Now what happens, that it will actually get asynchronously for you executed, which is pretty cool. They all depend on each other. Okay, multi-platform. What is multi-platform? So multi-platform allows you for sharing code. Oh wait, actually, I think this slide was here already. Sorry for that. Let's skip that. Okay, sorry, that was like extra slide that was supposed to be there. Okay, now we're getting to the last section of the presentation, and that is Kotlin in numbers. So let's look into that. Now this is actually interesting. This graph actually shows a code base. We actually share, this is actually AirBnB code base. We share the repo with iOS, so you can see there's some Objective-C and Swift. But you can see June 2018, this is the distribution of the files in our mobile repo. So you can see a lot of Java, 22%, a lot of XML, that's are all the layouts. And you can see Kotlin, it's like barely scraping, 3.1%, right? Very, very few. Objective-C Swift, obviously that's iOS part. Now, this is the same graph from April 2019, which is a few days old actually. You can see that Kotlin is all the way up to 9%, whereas Java is only 16 now, right? I also did like a small chart in terms of how many files we had for both Java and Kotlin in the past year and a half almost. And you can see that by the way, this is logarithmic scale. We have 100 here and 10,000 here. So you can see that Java is kind of like almost the same. There was like a peak around here, and it's actually started declining. On the other hand, you can see that Kotlin is like going up. So right now, Java is something around like 7,000 something. Kotlin is like almost close to 5,000 right now, and it's gonna keep going up. So I think at some point we'll actually surpass Kotlin will surpass Java. Now the reason for that, why don't we have our all code base in Kotlin? We don't actually fix old files. If you already have something that's in Java, it's actually, we don't recommend converting into Kotlin. It takes time, it's possible it's gonna break something, and also you become the owner for the new file for every single line, because you cannot keep track of the same file since you actually have to rename the extension. Sorry, the file extension has to be changed from Java to KT. That means you will lose the track of that. So we don't recommend actually converting for large code bases Java into Kotlin, but we do write all the new codes, all the new features in Kotlin. Now, we also did a survey actually last week with all our Android engineers. Not all of them filled the survey, but some of them did. So one of the questions was, I find myself to be more productive with Kotlin and Java, and we got these kind of results. I think actually kind of speaks for its own. By the way, when 1 is totally not, 10 is absolutely on the scale, right? So almost everyone you can see, the more right, the better. So a lot of people, 24 responses, decent. So a lot of people are actually happy. They do feel more productive with Kotlin. Another question was, the transition from Java to Kotlin was reasonable for me. And again, 0 is not at all. 10 is absolutely. You can see that as a distribution is slightly shifted towards the, not as much to the right as we would like it to be. One of the reasons is actually Kotlin is actually, it is a complicated language, I'm not gonna deny that. It's very powerful once you learn it, but it comes with a heavy cost. One of the last questions we had, and I think this is the most important one, would say, I would go back to Java if I could. And this is our response rate. So I'm actually quite happy with that. That's something we kind of hope for and expected, and it's great to see that actually coming from our developers as well. Now, this is actually another interesting survey from Octoverse. This is actually on public GitHub. In 2018, Kotlin was the fastest growing language. Now, that doesn't mean it's the biggest. It means it has the fastest growth, right? So it's worth mentioning. Kotlin is still not top 20, and it probably won't be for next few years, but it's growing a lot. Now let's talk about Kotlin adoption in the Silicon Valley, both actually backend and frontend. So I was able to pull some data and ask a few friends around. So obviously Google is using it, Square is using it, Facebook allegedly is using it too. Airbnb, obviously we are using it. Amazon, Netflix, Pinterest, Uber, Foursquare, Trello, Capital One, Coursera, Basecamp. All these big companies are using to some degree Kotlin either on their Android development or on their backend. I actually don't know anybody who would be using it for iOS development, but it would be cool to know. Cool. Now this chart I actually got from a Kotlin website. They pull up a number of developers from some websites. So in 2016, there was like 156,000 people who were contributed to Kotlin. 2017, 700,000. And last year, we got almost to 2 million. So you can see how Kotlin is actually growing in the number of users as well. Now, obviously, I don't want to just praise Kotlin. There are some issues. And I'm actually going to point out a few of them. It feels harder. It definitely feels harder than Java. It's less explicit. A lot of things are implicit. You have to kind of know a lot of things about Kotlin. You kind of need to really learn it to see, especially for example, when you're missing the types, it's not always clear what type a given variable is. You have to kind of backtrace it. So it's definitely harder to learn a bit, but I think it pays off with time. The initial learning curve is quite steep. It's also quite costly to switch the whole team of 20 people actually to use that. But we did that at Airbnb. We switched probably like 50 developers on Android, or how many we have right now, to actually be using Kotlin. So it is definitely possible. There's a problem with some annotations. They don't work well, especially the one with Lombok. If you ever used Java Lombok, that's actually a big pain in the ass. I have an example, if we have time, to show you what needs to be done in order to be able to support it. So it's some coding, but I don't know if we have time. There's some issues with the bug build system. We're actually using bug build, and we did have to go through a bunch of hoops to actually make it work on Android. A lot of people actually complain about the missing static modifier. I personally don't mind that. I think it makes sense, but I can see either way how people are, especially in Java, are used to that. Anyways, well, Kotlin has much more keywords. Kotlin also has like hard keywords and soft keywords. Soft keywords means it's a keyword sometimes, but not always. For example, catch, like you have try catch. If it's in try catch, it's a keyword, but you can name your variable just catch. It will work and compile fine because it's a different context. I'm not particularly happy about that either. I think they could have just declared everything to be a hard keyword and everybody would be happy, but whatever. Okay, a live demo. I'm actually gonna show you, this will be very quick, this will be less than 2 minutes. I think we should be okay on that. So I have this function, it's a main function. Let me actually zoom a little bit more. This is a Java class, and it has this method called data entity. Now, if you click through it, this is a simple data class. This one is using Lombok annotations, right? So this is the one that creates the constructor for you. That makes all the fields are non-nullable. So this is like one way to do data class in Java. Now, I want to show you how difficult is it to actually convert Java to Kotlin. So you click right here, and you click convert Java to Kotlin, and you hit OK. Now you get Kotlin, right? It's actually quite simple. It works in most cases. You saw it actually worked pretty well. Now we are fully in Kotlin. Now the only problem is, if I'm going to try to run this main method right now, let's try that. Let's see what happens. I get a bunch of errors. Now, the reason for that is that this data class is actually using, as I mentioned, the Lombok annotation. And Lombok is kind of doing a lot of hacky stuff. It doesn't really create a new classes for you. It messes up with the AST in place. It actually changes AST during the code generation and doesn't create a new class, so the Kotlin compiler cannot see them. That's actually very annoying for us. Now, there's a way to solve it. The way you would solve this thing is you need to add a new module. So you're gonna add a new module, of type Kotlin, whatever. I'm gonna call it, I don't know, data module. Doesn't really matter. Now I have a new module. Then what you need to do, you will need to move this class, this data class, to the new module. So I'm gonna do it right now. Let's put it into, I don't know, source Java, source main Java, right? Java / I don't know, what is it called? Lombok example. Right, so now we have the new class down here. So that's cool. Then I'm actually gonna also update the build Gradle because I already prepared this one, so I wanted them to be the same. Let me actually move the version here, it's not needed. And now we need to add dependency. Sometimes IntelliJ is smart enough to add it on its own. Sometimes it doesn't, so today, right now it didn't, I don't know why. I need the build settings, there you go. Include. And this is the data module. Right, so now you can see I have my data module here. I'm going to build it directly. I'm using Gradle, by the way, you can pursue much more. So you see it built successfully, so that's good. So our data class built successfully. So we have the data class here, that's purely in Java. And I can go back to the main method. Now you see this one is complaining right now. It says, well, something is wrong. So I'm just going to add dependency on that module again. Now I added dependency. Now I'm gonna try to run it. Hopefully it runs. Oh yeah, so I'm printing it down here, so you got the name right here. So yeah, this is what you will need to do if you use annotations in order to make Kotlin work in, Java work in Kotlin with some annotations. Unfortunately, Lombok is one of them. It's actually one heavily used across the industry, so you might hit it. The better way would be actually to convert this data class into Kotlin data class. It's actually super simple too. I don't think we have time to do that, but that would... Huh?
Let's do it.
Really?
Yeah.
Okay, well, so again, okay, sure. So it's actually not that difficult. I'm gonna actually use the same module for that. The way, again, you would do it, convert Kotlin to Java, okay, you get all this. Now, there's some manual work that needs to be done. You don't need any of those annotations anymore. Changes to be a data class. Yeah, that's pretty much it, really. And then bunch of commas here. And changes to be a constructor. Done. And now we have data class. And this one will compile just fine, hopefully. Actually, I haven't tested it, but let's see. Cool, so that compiled. And now let's go back to the main function. And if God allows, it will actually run. It's cool. And now the good thing about that, since it's already converted into Kotlin, you can just actually move it back. You can just actually move it back here, and completely get rid of the module. Sometimes the thing is, sometimes it's cheaper to move just things into the new module because those data classes can be a bit more difficult to convert. It could be a bit more work. I would actually recommend, if you can, just convert it to a proper Kotlin data class and be done with that. But sometimes, for example, in our case at Airbnb, those Java classes, the Lombok Java class actually gets auto-generated from a thrift file because there's actually converters to do that. So there's no way somebody could go and manually convert it. That's why it's only one way for us to handle it is actually to generate those Lombok annotated data classes into its own module, then build its own module and link it through an extra project. It's a little annoying. It depends how your build system is set up, really. All right, so that was live demo. It's something actually we struggle a lot. But as you can see, like converting file from Java to Kotlin is as simple as just selecting that file and saying convert to Kotlin. Now the converter doesn't work always. There are some cases where you have to always go and do like a manual, like a tweaking. But for simple files, it actually does a pretty good job. Cool. So yeah, have a good Kotlin. Thank you, everyone.